All right, so this video is going to go over pages 22 and 23 in your Newton's Law packet. So now what we're going to do is what we've been talking about is net force equals mass times acceleration. So remember, net force just means the total forces acting on an object. Now, in realistic life, okay, you're going to have friction that's involved. So what we're doing now is we're bringing friction into the mix. Okay, so F net equals FA plus FF. So FA is your applied force. That's the force you're applying to an object to make it move. Okay, and then your FF is your frictional force. That's the force that's trying to slow you down. Now, typically, your applied force is going to be considered positive, and your frictional force is going to be considered negative since it's going against you. So this is the same thing as saying FA minus FF. Okay, so what we can do is we can plug that into our F net equals MA. So just do FA minus FF equals MA. So it's the same thing, it's just now we're taking friction into account, okay, because friction is normally present in real life, whether it's by a surface, through drag, things like that. But for now, we'll just worry about just basic friction. So, example, what is the acceleration of a 2 kilogram object? So that is my mass. I'm looking for acceleration. Okay, if it has an applied force of 30 newtons, so there's your FA. To the right, we're going to pay attention to that. Just if anytime we see direction, you want to kind of pay attention to that. And a frictional force of 20 newtons acting on it. Okay, so there's your FF. Okay, so if I were to draw this out, okay, so I basically have an object that's being pushed. We have an applied force to the right, so FA would be 30 newtons. Okay, and then your FF is going to be going the opposite way, and you've got 20 newtons, so I'm not going to draw the arrow as big. So 20 newtons would be my FF. Okay, and then normally you're going to have your FG acting on it, your force of gravity that's pulling it down, and then your normal force that's pushing right back up. Okay, so remember, your normal force is the force of a surface that's pushing back on the object. So like right, if you're sitting in your chair, okay, you have a gravitational force that's pushing into the chair, and the chair is pushing back with a normal force. Okay, this question didn't really ask for that, but we're just kind of drawing things out. And our mass is 2 kilograms. Okay, so I'm trying to find the acceleration. So we know FA minus FF equals mass times acceleration. Okay, so FA would be 30 minus your frictional force, which would be 20, equals mass, which is 2, and A we don't know. Okay, so 30 minus 20 is 10, and then divide both sides by 2, and you get an acceleration of 5 meters per second squared. Now, don't forget that acceleration, all these are vectors, so if I mention a direction in the problem, then we just want to keep it in the problem, in the answer. Okay, if they don't mention direction at all, okay, we would know by either positive or negative. You don't have to worry about writing a direction. So, if only a friction or braking force is acting on an object and slowing it down, the net force and acceleration would be negative. That means in this case there is no FA, so FA would be gone. Okay, because if friction is the only thing that's happening, so if I were to draw this out, here's my object. Okay, we'll just say it's going this way. Okay, and there's no applied force. If you're tapping the brakes, you're not applying a force to, like if you're in a car, if you press the gas, you have an applied force. Okay, but if you're not pressing the gas, or you just kind of let off the gas and let friction kind of slow you down, or you press the brakes, that means the only thing that's present is a frictional force that's trying to slow you down. So in this case, your net force would be negative because that's the only way the force is going is against you. Okay, so that is basically just saying that if there is no applied force, the only force that's going to be there is negative because it's going against you. Okay, so let's look at the next example. Sorry, this one kind of came out a little blurry. We have a 1,000 kilogram car, so there's your mass, is moving at 30 meters per second. Okay, there's a velocity. We don't know which one it is yet. We'll find out. Is brought to rest. Okay, so that just told me that VF equals 0. That means this is VI. Okay, so if you get confused on velocities and which one's which, just read the context of the problem. Okay, if you see terms like brought to rest, that means it comes to a stop. That means your final would be 0. And if you see things like starts from rest, okay, that means your VI would be 0. Okay, or if it mentions anything about what is my new speed, like I gave you an original speed, and what's my new one? Okay, so you just kind of got to read the context of the question to figure out what do you have and what are you looking for. And then it says it was in 25 seconds. There's your time. What is the frictional braking force? So FF would be your question mark. That is stopping the car. That means if you're stopping the car, you're pressing the brake. That means FA does not exist. Okay, there is no applied force. You're hitting the brakes. You're not hitting the gas. So you're only looking for FF. Okay, so remember when we were doing these problems on the homework before we left for the break, what we were doing is we were mixing Daffy T and F equals MA. Okay, remember A is the only thing that can go back and forth. Okay, so the trick to doing this is you need to figure out what do you have and what are you looking for. So in this case, I'm looking for force, so I'm looking for this right here. So in order to do that, I would have to have mass and acceleration. Well, I've got mass, but I don't have acceleration, so that means I can't just jump into F equals MA. That means I have to use Daffy T to help me find A, and then I can bring it over to F equals MA. So we're going to set up our Daffy T, so dA, VF, VI, and T. Okay, so A is what we're looking for because we need it. Okay, VF would be 0, VI would be 30, time would be 25. That means we did not care about distance. Okay, so what we're going to do is make sure you use the right equation. If you look on your Daffy T equation chart, you don't use the equation that has the question mark. So I'm not going to use equation number 2 because if you look at that equation, A is not even in it. Okay, so it's going to be kind of hard to solve for A if it's not even in the formula to begin with. So you're going to use equation number 1, which is VF equals VI plus AT. So 0 equals 30 plus A times 25. So what I would do is I would bring 30 over to the other side. It becomes negative, and then divide both sides by 25, and you get an acceleration of negative 1.2 meters per second squared. Okay, so now I do know my A. Okay, so in this case, normally what we would do is we would say FA minus FF equals M times A. Well, FA doesn't exist, so pretty much that just means FF equals MA. Okay, because frictional force is the only force that's happening in this problem. So we're just going to plug in our mass, which is 1,000. Our acceleration is negative 1.2. So just multiply those. That means my frictional force is negative 1,200 newtons. And that's it. Okay, which should make sense. If you have a braking force and that's the only force that's happening, it should be negative because it's going against you. It says, if an object is moving at a constant velocity, so watch out for constant velocity, there are balanced forces. That means everything's nice and balanced. There is no uneven forces. This often means that FA is equal and opposite to FF. Okay, so that means I have like an object here. That means my FA is going to be the same as my FF. So remember, this is kind of a recap. If you're moving at a constant velocity or if you're sitting at rest, that means your acceleration is 0. Okay, and if we look at this equation F equals MA, if A is 0, that means anything times 0 is 0. So therefore, your net force has to be 0. Okay, so anytime acceleration is 0, that means your net force is 0. That means you could either be sitting still, okay, or that means you could just be moving at a constant velocity where your FA and FF are balanced. So those are both scenarios on where F net could be 0. Example, next one, a 50 kilogram baby carriage, so there's your mass, is being pushed along a rough sidewalk with an applied force of 200 newtons, so there's your FA, has a constant velocity of 3 meters per second to the right. So I was given constant velocity 3 meters per second, and I was given a direction. Okay, so keyword there is constant velocity. We're just going to keep an eye on that. What other horizontal force is acting on the carriage, and what is the magnitude and direction of the force? Okay, so we're just going to draw our carriage that's being pushed along the surface. So I have an applied force, and it doesn't matter. So in this case, it's going to the right, but applied force can go any way. Okay, an applied force is not always to the right. It just depends on the problem. So it could be left, could be right. You got to make sure you read the problem. So your FA would be 200. Okay, so there's your FA. Okay, you have your force of gravity that's pulling it down, and then the surface is pushing back up with Fn. Okay, and it says what other horizontal force is acting on it? Well, if I want to keep this going at a constant velocity, that means my frictional force has to be the same as my applied force. Okay, so that means my FF is also going to be 200 newtons, just the opposite direction. So the way to kind of think about that is if you want constant velocity, they've got to be the same. If you want it to accelerate, that means FA has to be bigger than FF. Your applied force has to be bigger than the frictional force. And if you want it to slow down, frictional force has to be bigger than applied force. So my answer was this. The other horizontal force that's acting is 200 newtons, and it's acting to the left. Okay. B, what applied force, that means you're looking for FA, would have been required to accelerate, so that now we have an imbalance. The carriage from rest, so VI equals 0, okay, to 5 meters per second. So there's your VF. And that little R right there means to the right, so we'll just kind of keep an eye on that. And you have 2 seconds for your time, assuming that friction would be the same. So that means we're going to use FF from the previous problem, which was 200 newtons. And then don't forget our mass is the same, so our mass in this problem is 50 kilograms. So we are looking for FA. So remember, FA minus, FF equals M times A. So we're going to see, do we have enough? Do we have FF? Yep. Do we have mass? Yep. Do we have A? Nope. Okay, so we can't solve that problem just yet. So what we're going to do Daffy T to find that A, and then we can bring it over to kind of help out. So A is your question mark. VF would be 5, VI would be 0, and T would be 2. So that means distance doesn't matter again. So we're going to use equation number 1. So VF equals VI plus AT. So 5 equals 0 plus A times 2. So 5 divided by 2, and I get an acceleration of 2.5 meters per second squared, and that is to the right. Okay, so that's not our answer. That is just our A that we're going to take over to our next equation and fill in. Okay, so FA, we don't know, minus FF, which is 200, equals our mass, which is going to be 50, times our acceleration, which we just found was 2.5. So now I got to do my math, so 50 times 2.5, and then add 200 to both sides, and you get an applied force of 325 newtons, and that is to the right. All right, so that will end that video. So the next video will just be more practice using FA minus FF.